Some of you are being a little rude. Where did I stop? Did I stop at number 11? I went to 13 or stopped at 13? Okay. So can I start at number 13? Is that okay? Going once? 13, okay? 12? Okay. Oh, okay. So number 12. All right. So if we were to talk about this, all right. What are some things that you know? If I were to draw what the basic foundation of this graph would look like, it would look something like this. So what are some things you think might start happening? What kind of transformations might we get? The graph shifts down, -8, okay? So basically this point moves down 8. Okay? That's definitely something's going to happen. Do what? What about the 3? I'm sorry. Left. Yep. Because of this is a grouped portion, so that means it's going to move left 3. So this point was here, now it's going to go this way. Okay? So if I didn't have the negative out front, this is what this graph's basically going to look like. If I didn't have the negative out front, if I ignore this negative, that's what the graph is then going to look like. So the point that was easy to identify was on the y-axis. Dropped down 8, moved left 3. First off, what would the 5 do to the graph? Yeah, it would stretch it. It's stretching by a factor of 5. What does the negative do, though? Let's it across the x-axis. Okay, I am going to say you're like totally right, but I want to change your term just a smidge. And this is why I want to change it. That -8 is actually taking what the x-axis would be and it's moving it down. So it's not going to reflect it across the x-axis in this case. Good. Oh, you don't have to take tests tomorrow. You got an automatic A. Hey, you all have the same option. Alex, you always got to take it. Yours are easy to grade. You leave yours blank. So, okay, this is going to flip over the horizontal asymptote. So it's going to do like that. Okay? So I'd say you probably see that kind of problem. It's not horrible. So does the base of 2 really do much to this problem? No. I mean, it's just 2 to an exponent is all we're dealing with. If it was 3 to an exponent, your graph's going to look the same. 4 to an exponent, same. 5, 6, 7, 8, whatever to an exponent. I mean, it might grow steeper, but for the most part, that's what it's going to look like. Borrow yours again. I'm picking on you today. All right, 13 and 14. All right, identify the functions as modeling is either growth or decay, and then give their percent increase or decrease. Okay. What is this one? Why is it decay? What is between 1 and 0? The 2/5. So this right here is between 0 and 1, so that means it's decay. Okay? Now, we have to make sure that that exponent isn't negative. Is it negative? So it's still going to be decay. Now, we want to figure out what the growth factor would be. So remember, this region here, if I have y equals ab raised to the x, if you take your b value, it's going to be 1 minus some unknown in order to get there. And the reason I say it's minus is that's decay. It's going to be 1 plus if it was the other way. All right, so if I were to take my b value, which I know is b 2/5, set it equal to 1 minus question mark. If I wanted to solve for question mark, how do I do it? Subtract the 1, okay? So if I subtract the 1, which is 5/5, if I subtract 5/5, so if I go 2/5 minus 5/5, I get negative 3/5. Someone was close. Okay, both negative, so my question mark is going to be 3/5. Okay, that is my decay rate. 3/5 is the same thing as 0.6. 3 divided by 5 is 0.6. 0.6 is the same thing as what percent? 60%. So this has a 60% decay. Is that okay? Let's say that one more time. I hear you so much. Because you have negative question mark equals negative 3/5. Because in a problem, they will say this is the decay rate of this. You're not going to say it's minus this. So when you hear decay, you're going to know it's going to be associated with a negative. All right. Second problem is the exponent positive or negative. Positive is my base between 0 and 1. It's my base between 0 and 1. No. So this is going to be growth because that's bigger than 1. Okay? So again, let's figure this out. This is a b value. I know that my b value has to be equal to, in this case, 1 plus 2.25. Sorry. 2.25 equals 1 plus b. How do I solve for b? And why is it plus? Because it's growth. So I'm going to subtract 1 from both sides. So I'm going to get b is equal to 1.25. So my growth rate is 1.25, or my growth is at 125%. Okay? So things can grow at higher percents than 100%. But you know, I'll just give you a little piece of advice. When you're interviewing for a job one of these days, don't say, hey, I'll live 110%. You can't give more of your time than there already is. You know, if you truly say, hey, I'll give 110% of work, that basically means for every 100 hours of work, you're going to work 10 hours for free. Are you really? But I think if I was a boss saying, hey, they're going to give 110%, I'm thinking I'm saving money by hiring you. But are you really willing to do that? So don't say it. Don't give above the 100%. I'll give 110% of this job. Oh, obviously you're sitting here for a reason because you want the job, but you really want the job because you're willing to work for free for me in order to get the job. I don't think you're going to do that. Maybe you will. I don't know. All right, number 15. You have, this would be nice. You have inherited land in Aspen that was purchased at $30,000 in 1960. The value of the land has increased by 5% per year. So it was purchased in 1960 at 30 grand. It's increased. Write the equation to model the value of land over time. Write the value of the land this year, so it's 2014. And then when will the land be worth 5 times its original value? Include a rough sketch with your calculator with your answer. Okay, so problem number 15. We have 30,000. What happened? Sarah, what are you doing? Okay. Here we go. So using y equals ab raised to the x power. ab raised to the x power. What is my a value? What? What is my a value? 30,000. So a is 30,000. It's growing. It's a growth factor by 5%. So what's 5% as a decimal? 0.05. Do I add or subtract with growth? I add. So 1 plus 0.05 is 1.05. This is raised to the x. So this is our equation for this graph. It's growing at 5%. 5% as a decimal is 0.05. If it's growth, you add 1 plus. If it was losing value, you would go 1 minus that. That's why it's growing. All right. I need your help. So x is time in years. We started in 1960. We want to know what the value is in 2014. How many years are we talking? 54. So I'm going to go y equals 30,000. 1.05 raised to the 54 power. Somebody help me out. You have the calculator? 30,000 parentheses, 1.05 parentheses, caret, 54. How much? Sarah, what are you doing? You're off task. Yeah, you are. Making Alex look like a good kid over here. Go ahead. 400 and what? 160.88. Sounds good. So you inherited something that was worth $30,000 54 years ago, but that's what it's worth now? Is that an okay inheritance? Heck yeah. Now, if you choose to do something with that land in Aspen, good. Or if you choose to sell it, you got some cash money in hand. Huh. All right. So we want to now know, we would like to now know, when exactly is this going to be worth 5 times its original worth? Okay, so I'm going to graph, you need to graph this equation on your calculator. But then you also need to graph this. This will be under y2. So 5 times its original growth. So 5 times that is going to be 150,000. You're going to graph both of those. And if you graph both of those on your calculator, you got to make sure you do a zoom fit because it's all not going to fit in the -10 to +10 window. Okay, so graph both of those. And what's going to happen is you're going to see on your calculator, once you get your zoom fit or your zoom out to a certain amount, you're now going to get something that's doing this. That's the other line. What I want to do is I want to find where they intersect at. Where you find where they intersect at, that's going to give you an x comma y value. Okay? I will tell you the y value at that intersection is going to be 150,000. What's the x component going to be? What do you think? What's the x component going to be? You got to make sure you zoom out. You got to make sure you see the picture on your calculator before it will do an intersect. When you do the intersect, it's going to say equation 1, hit enter, equation 2, enter. It's just doing the first and second equation. Then it's going to say guess. No, let's not guess. Let's hit enter one more time. And then I'm looking for the x component at that thing. The y component will be 150,000. Zoom fit might make it show up. Does it? Okay. So if you do a zoom fit and then do a zoom, try and get to where that point would be and then do a zoom out. And sometimes it might be hard to see it. If your window is like in the trillions, you'll see it. Yep, so it's going to be, so I can calculate. We're going to find the intersection, which I believe is number 5. Did you get that right? Is it? So then look for the intersection. Give me what? What? So that other line is y equals 150,000. So you're not able to see your x-axis with where it's zoomed to. You're like way up to the right. Yeah, you don't need to have your step plot on. Just give me 1 decimal of the x. So 33. 32.9. All right. Shh. This is going to give me 32.9. Shh. So, when would this land be worth 5 times its value? Would this land be worth 5 times its value? Started in 1960. What's 33 years added on to 1960? 1992? Sweet. So in 1992, approximately, 92, 1993, depending if you round it, your land is worth 5 times its value. Do you think if you held on to something for 33 years and it became worth 5 times its value, would that be a pretty good investment? I would hope so. What's the what? $1. $1, you do, you got $5. No. I bet you it did stuff like this. I bet you back in the day it was kind of junk land. It was like Telluride back in the 80s. People like Telluride going, why don't you go to Telluride? It's hard to get to. I mean, people were like, I remember a guy across the street from me growing up in Arizona was like, I was thinking about buying this small little house in Telluride. And it was like dirt cheap. It was like $6,000 for a house in Telluride. It was ridiculously cheap. This was hard to get to. People were like, oh, why would you go there? But some of the greatest technical skiing out there. That house now, you would have retired 5 times over. His kids would have retired. I mean, ridiculous. Yo. Yeah. Nice. Ridiculous money. Wow. Yeah. All right. Shh. Alex, quit being a punk. Send you back to Parker.
I was kidding.
All right, here we go. So, I'm pretty sure the test is going to allow you to use your calculator, but if I'm looking for specifics on stuff, it might be a little tougher if you don't have the basics down on this. So, item 1 on number 16, it's going to be a decay model. How do I know? It's between zero, the base, whatever's raised to the exponent is between 0 and 1, so it's a decay model. So if you were to have graphed this, it's going to probably look something like this, I'd say. You think?
Yeah.
I draw right?
I agree.
Yeah.
Yeah.
No.
No. I agree.
All right.
I concur.
I hope so. All right, so if you were to go and try and make a t-table, so when I do t-tables, I think if you go -2, -1, 0, 1, and 2 are pretty good things to plug in, but sometimes you might have to go to -3, sometimes you might have to go to +3, sometimes -4, sometimes +4. It all depends. What happens if my item becomes a negative exponent? What happens to the fraction? It flips, okay? So, let's think about this t-table. Let's think about this t-table. If I plug -2 in for x, I get -2 plus 2, which is 0. 1/4 to the 0 power is 1. 1 minus 3. Okay, that seems like it worked out okay. Let's put -1 in there. -1 plus 2 is 1. 1/4 for the first. 1/4 to the first is just 1/4, or 0.25. So 1/4 minus 3 is -2 3/4. I'm not quite sure how much these are going to start helping me out with this fraction. Not sure how much, because if I plug 0 in, I get 1/4 to the second. 1/4 to the second is 1/16. 3 minus 1/16 is -2 and 5/15/16. So that's not really helping me all too much on the graph. So let's start looking the other way. Let's go, well, what happens when we get to -3? If I plug -3 and I get -3 plus 2 is -1, what is 1/4 raised to the -1 power? 4. 4 minus 3 is 1. Okay, that's graphable. What about if I did -4? -4 plus 2 is -2. -2 is going to do it to the fraction. It's going to flip it, so 4 to the second. 16. 16 minus 3. Okay, so if I were to actually graph this, -4, +13. Okay, so my graph's off a smidge. Right? -3, 1. -2, -2. 0, I'm not even worried about what's going on with 0, so this is actually doing this. So, my assumption on my graph, I was incorrect thinking it. I just knew I was going with decay, but I didn't realize it was going to be going decay that way. You see how I made the t-table work for us? Am I worried about 1 and 2 when I plug those in? They weren't conducive to my graph. You have to be wise about it. So you start out with a -2 to +2, and then you might have to do -4, -3. You might have to do 3 and 4. It just depends what your exponent's raised to. We okay with this problem? Oh, what's the domain? Negative to positive infinity. Love it. What's my range? So it's positive infinity to where? I'll go with that. Hey, what is my horizontal asymptote? So what is my range? What's my range? So it's coming from infinity, but I have this. That's going to be -3. So it's going from infinity to -3. Be careful on that. Okay? We okay so far? Ready to move on? You need to poke your neighbor in the eye or anything? Keep them going? Get my permission to. All right. Growth or decay? Growth or decay? Sure does look like growth, but we got that negative hanging out in front. What's that negative going to do? Okay, so if it truly was growth, it's probably going to do this. What is this negative going to do to our graph? Flip it where? Is it flipping it over the x-axis? Is it flipping over the y-axis? What's it doing? Okay. Let's make a t-table and verify. I think you're right. We'll make a t-table, make sure we're good. Shh. All right. So plug negative 2 in. What's 2 to the negative 2 power? 2 to the negative 2 power. 1/4. Good. 1/4 times negative 3. Negative 3/4. Okay, so negative 2, negative 3/4. No coughing. All right. Plug negative 1 in. 2 to the negative 1. 1/2 times negative 3. Negative 3/2. So that's negative 1, negative 1 1/2. Plug 0 in. 2 to the 0. 1. 1 times negative 3. 1 times, what is it? Negative 3. 0, negative 3. If I plug 1 in, 2 to the first is 2. 2 times negative 3, negative 6. This might be about as far as we should go on this. Negative 6 is going to be further down here. So that looks okay. Hey, what's my horizontal asymptote? Let's do this first. What's my horizontal asymptote? X equals 0. I'm sorry. Oh, excuse me, y equals 0. Okay, so what is my domain? Negative, positive, infinity. I like it. What's my range? Good. Real good. 0, negative, infinity. Both rounded brackets. Love it. Did I need to worry about plugging 2 in and getting negative 12 out of it? I guess we could have, but... I think some of these you'd probably be able to get away with 3, except for if it's natural log, and I'm going to get to that one 2 problems from now. I think, yeah, down on that one. 2 points might be good, but realize here's the hard thing with 2 points, Isaac. 2 points defines what? Straight line. So that I get going. You know that you have a curve. I get it, but I think your geometry teacher might frown. But if you don't tell them, you'll probably be able to get away with 2 points. Just don't walk back. Dude, start the best he allows me to say 2 points for an exponential, and you're like, fine. And then I get someone come in here. We don't teach things like that here at Creek. Sorry. I have no idea what this graph's going to look like. It's logarithmic. So, let's think about this. T-table. All right. Some things I want you to consider here. I want numbers that can be formed as exponents with a base 2. I want numbers that can be formed. I want numbers that can be formed in base 2. So I think I could go, can I do 0? Actually, I think 0. If I do log of 0 of anything, I get undefined. If I get negative here, negative can't go there because log can't exist in the negative region. As far as this goes. Okay? Now, a lot of people say, hey, let's go with 1. And I think you're absolutely right going with 1. But 1 is, how do I get 1 using 2 as a base? 2, what do you mean, how? Good. So 2 to the 0 power, 2 to the 0 power is the same thing as 1, right? So if I were to take 2 to the 0 and plug it right in here, what does log base 2 of 2 do? Log base 2 of 2 is equal to 1, but if you're raising it to the 0, what does this exponent do here? So if I had this, what does log and natural log do with exponents? Bring them down. So if I bring this down, this gets multiplied right here. So I get 0 times 2 times log base 2 of 2. 0 added to 1? 1. Okay? All right, so what's another number that we can make in base 2 and have an exponent? I'll go with 4 in a moment. There's one before that. 2 to the what power? I can say that 2 is the same thing as 2 to the first. Do you agree? 2 is the same thing as 2 to the first. So if I plug this in, I'm going to get 2 log base 2 of 2 raised to the first plus 1. This brings exponents down front, right? So this becomes 1 times 2 times, what's log base 2 of 2? 1 plus 1. Order of operations, 1 times 2 is 2, times 1 is 2, add to 1. Okay? Now let's do the next one. What's another base 2 number? So 4 I agree with. 4 is the same thing as what? 2 to the second. And what would the next one be? 8 is 2 to the third. 16 is 2 to the fourth, so on and so forth. So again, if I take, I'm not going to worry about 2 to the third, but if I take this and plug it in up here, I get 2 log base 2 of 2 to the third plus 1. What does logarithm do? Not the 2, 3. So I get 3 times 2 times, what's log base 2 of 2? 1 plus 1. 3 times 2 times 1 plus 1. Perfect. So if you graph this, made this graph, 0 is not going to work. It's undefined. So I'm going to get 1 comma 1. I'm going to get 2 comma 3. I'm going to get 4 comma 7. So, you that right? 4 comma 7.
No, because you did 3 for 4. You did the exponents.
I did what?
No, 'cause
That's not working.
you should have done 2 as the
You
exponent.
did, yeah, we were doing.
You did it
So
for
it's not 4, 7.
8.
It's 4, 5.
Well, what did I do? Oh, dude.
But why?
Because look, you should have said it should have been 3. It should be 2 times 2 times 1 plus 1. And you did 3 times 2 because you did the different exponent.
Oh, dude, thank you. So that should have been a 2, is that what you're saying?
Yeah.
That should have been 2.
I told you.
That should have been 5.
Yeah.
I'm sorry. Alex, I thought you were my wife. I was ignoring you. 4 comma 5. 1, 2, 3, 4, 5. Okay. So this is doing something like this. Something like that. Let's say open dot going that way. Why am I not bringing this down here? It's not going to happen. Or is it going to happen? Let me ask you this. Someone on a calculator, just do this for me. Just for laughs and giggles. Just for laughs and giggles. What is log of 0.1? Just go log 0.1 on your calculator. You get negative. Log of 0.1. Negative 1. So it is going to exist down here. Okay? Hey, thank you for the little.
Catch you.
Again? What'd you do? All right, this time we're all going to run and hide. Robinson, who are you going to blame today? Alex. Blame Alex.
No problem. What are you doing?
What are you? She's so.
Robinson, if you need to do some name dropping, you can drop my name with them. And if all else fails, it's okay to cry in front of them.
Maybe. You got a ring.
Huh? I got a ring?
State championship. That's all you have to say. That's all he has to say to him. He wants state championship.
Oh, yeah. I went to the ship. All right. You guys ready? Domain. I would say our domain has to go from 0 to infinity. Okay, because I could plug really small decimals in. I can't plug 0 in, but I could go log of 0.000002, and it's going to give me a big old negative value way down yonder. Okay, and then the range. The range, how far is that going down? Infinity, how far is that going up? Negative, positive, infinity. Sweet. What's undefined though? Look at the graph though. Think of the range as an elevator. If you were to take your elevator straight down the y-axis, do you still see the graph if you look out of the elevator? That's where the domain is going to come in. But if you did like log base whatever of a decimal, it's going to give you a negative answer. So the range is going to result in negative answers. You just can't plug a negative number in with the log and natural log.
Could we skip the next one and go to like the back page?
Sure.
Okay.
Why don't I hit natural log tomorrow before quiz?
Okay.
All right, so I can go quickly. I'm going to skip that one, come back to it. Negative 4 equals log base 5 of 1 over 625. Shh. So, if we're going to write this as an exponential function, flip it over. Shh. Is that okay so far? Is that okay? Watch. You're going to see. I'm going to start right here. I'm going to go this way. So this is going to go 5 to the negative 4 power equals 1 over 625. And then if I add 7 to the third power equals 343. Let's write that down. If I add that and I wanted to write this as a logarithm, make sure the exponent stuff's on this side, which it is. You start here, you're going to go around. And you're going to say log base 7 of 343 is equal to 3. That okay? Do what? So you make sure that your exponent stuff or your log stuff is on the left side of it. If it's not, you flip it over. $31, I'm pretty sure you'll be able. So on 31, that kind of problem, you're going to plug your data in, which I know you've been doing on like crazy. And what that's going to do for you is you're just going to have to do the exponential regression. Don't go linear, then quadratic, then trinomial. Go right to the exponential regression. Okay? And then 22, you would have to solve it. You have to realize 8 is the same thing as 2 to the third power. So what's log base 2 of 2 to the third? 3. Have a great day.
Should I ask?